Hello friends, welcome to another video on the Python Novice to Pro channel. Now on the screen you can see a bust of Julius Caesar, and you'll be wondering what's the relationship between Julius Caesar and Python programming. Well, I'll tell you a brief history of Julius Caesar. Julius Caesar was an army general and a statesman. He fought several wars and he won the Gallic Wars in Rome, and this promoted him to be one of the emperors of Rome. And during his time, because of his need for secrecy as a Roman general, he had to invent what we call the Caesar's Cipher or the Shift Cipher. This is just a code, a cryptographic technique of sending messages through secret channels. In the Caesar shift, what Julius Caesar does is that he takes a letter in the alphabet and he shifts it 3 places to write his messages. For example, if his messages contains an A, it will be shifted 3 places to a D. If it contains a B, it will be shifted 3 places to an E, and so on and so forth. So that's how he sends secret codes to his troops on the field for them to fight their wars. So you can now see how Julius Caesar is related to coding. Today, Caesar's shift or his cryptographic technique is studied in several places because it serves as a good introduction to cryptography or writing and encrypted messages. Now, this is a code I wrote that implements the Caesar shift. It's just a simple code. You can see that there are 2 functions in the code, the encrypt function and the decrypt function that starts from line 9. In the encrypt function, it takes 2 arguments, the plain text and the key. So you just give it a text you want to encode, and then you give it the key for the encryption. So what it does is that it goes through in line 3, it goes through each of the characters in the text, and if the character is an alphabet in line 5, what it does is shift it. It takes that character, this ORD accepting a character function just converts the character to a Unicode number, shifts the character by the key numeral, and then shifts it backwards again by 97. So whatever number you get in this parenthesis, you take the modulus 26 and shift it forward again by 97. You convert the number you finally get using the CHRO function to a character. So that's how you do this line by line, character by character in the text that you enter. Now, then in line 7 you get your encrypted text. In line 9 we see the decrypt function. The decrypt function just decrypts the encrypted text you got from the encrypt function. What it does is that for each character in the encrypted text in line 11, it shifts it back, it retraces the shifts you did in the encrypted text. It just retraces all the shifts. When the encrypted text you shifted the character forward, in the decrypted text it shifts the characters backwards, and that's when you get your plain text. So I wrote this main function here that shows how you can use it. So it's in line 20, asks if you want to do encryption or decryption. If you want to do an encryption in line 21, what it does is feed it the text to encrypt, it's feed it the key, and then it calls the encrypt function and gives you the encrypted text. But if you want to do a decryption, you must already have the encrypted text. So in line 26, if you tell it you want to do the decryption, you give it the encrypted text, and then what you do is that you also give it the key you use in encryption. So you must already know the encrypted text and the key. Then it just simplifies everything. Then it decrypts it and prints out your text, your decrypted text or original text. So let's try it out. Let's try it out how the function works. So I click run. It's asking me, do I want to do an encryption or decryption? So we don't have a encrypted text, so let's do an encryption. Let's tell it E for an encryption. So the text, I give it someone's name, then I tell it I want to run key 5. So you can see the encrypted text is SSFJRJPF. So it has encrypted this Nemeka here to SSFJRJPF. Now let's run the decryption. So I'll give it a D. So you say enter text to decrypt. I'll give it the encrypted text SSFJRJPF. It's asking for the key used for encryption. If you use the wrong key, you get the wrong result. So since the key was 5 we used earlier, we decrypt it using key 5, and you see it's giving me back my original text Nemeka. So that's it. Now asking for a rerun, I tell it no. So that's it. You see, in this code, we already know the key used for encryption. Now, what if we don't know the key used for encryption? For example, it's not we that encrypted the text. I wrote another. We can use a brute force method to decipher what was the original text, or we can use frequency analysis. Now, this is a code showing a brute force method that one can use to find out what the encrypted text was. So I call it brute force Cipher. So in the brute force function, what you just do, you just give it the encrypted text, the text you want to decrypt, and then it goes through each of the keys corresponding to the number of letters you have in the alphabet. So it goes through from 1 to 25. Then it takes each character in the cipher text or the encrypted text, and it tries to reverse what was done in the encryption. Then as it reverses it for each key, it will be giving you suggestions on what was the likely original text you had after the decryption. Then your duty now is to scroll through all the 26 suggestions and find which one would be the likely original text the person who encrypted it used. So let me just show you now how it runs. Let me show you now how it runs. Say enter text to decrypt. We have our encrypted text, which is SSFJRJPF. That's the encrypted text. Then you see it has given us 25 suggestions on what was the likely original text. So I'll just scroll through and we'll look for what would be the likely original that this person used. You can see from key 1 to key 4 are unknown words. Then key 5 tells us it's likely Nemeka. So that's it. We choose key 5. If you consider all other alternatives, they don't look like words except key 5, the plain text of key 5. So we choose Nemeka as the original text. So that's how you can write the code for encryption and decryption. But I would like to tell you that Cipher is not used any longer in production because it can easily be hacked. If you use this frequency analysis code, you can easily know the key used for the encryption, and then you hack out the encrypted text, knowing what was originally the text. So you can use other encryption methods for more security, like AES and other modern methods. So you can Google it for other modern methods you can use. So that's it for this video. I hope you did enjoy knowing about Cipher. And if you enjoyed the video, I encourage you to subscribe to this channel and also like this video, because it encourages me to create more videos like this. So thank you for watching this video. I hope to see you next time.